I'm going to speak about machine vision applications in mussel processing. First, I'm going to introduce my company, ANFACO. ANFACO is the national association of companies in the canning sector. Nowadays, we have more or less about 250 members. And we have companies not only on the canning. We have companies that produce frozen products, smoked products, even integrators, machinery manufacturers. Also, ANFACO is a technological center where we provide technological support to the sector from different areas. Okay, for example, we have technical assistance. We have analytical area. We have research and development department. And also we have a pilot plan where we developed the projects, and this is all more or less. Then I'm going to speak about the mussel production in Spain. Spain is the main producer in Europe of mussels. And Galicia is our country is the most important region of production of mussel. Okay, we have about 3,300 rafts or floating structures here in Galicia. In 2022, we produce about a quarter of million of tons. Okay. It means about 160 million of euros, and how you can say it's an important economy for Galicia. Now I'm going to speak about the vision applications. We have split the types of inspection in two categories. Fresh inspection, it means with shell. Perhaps this is the category where you can find more industrial solutions. Okay. Then a second category, cooked mussel meat inspection. In this case, it's more difficult to find industrial applications. Okay. For ANFACO, we have been working in this area for detecting foreign bodies and other applications for doing nutritional measurements of the mussel. In this case, with the spectral camera. Okay. In the first category, fresh inspection with shell. The inspection take place after the cleaning process. Okay, with these systems, they want to look for the following defects. Okay, cracked or broken shell, loose shell, hole in shell, mussel fillet with sands, rocks or mud, or empty mussel. Okay. These vision technologies usage are RGB cameras and X-ray. Okay, X-ray provides density imaging, and with RGB you get a inspection of the surface of the mussel. Then the second category, cooked mussel meat inspection. This inspection is usually done before the packaging of the mussel. And how you can say in the photo, it's normal to find people carrying out this visual inspection, looking for the following defects. So, piece of shell, holoturia, little wraps, heritage, and an important byssus. Byssus is the hair used by the mussel to cling to the rope. Okay, and there are machines to remove these byssus, but it sometimes is not completely removed. Okay, and this is a problem. 5 years ago, ANFACO worked in a project where a machine was developed to automatic inspection of cooked mussel meat. The machine was developed by Impromar company. It's a machinery company from here, from Galicia. And the machine was divided in 4 modules. Okay, first module is a vibrator area. Is important module is for separating the muscles to facilitate the imaging processing. Okay, then a near camera, then RGB camera, and last ejection system with mechanical fingers or pneumatic plows. Okay. What is the problem for using RGB cameras for detecting the foreign bodies? Okay. If you analyze the image of mussels, you can see that there are high variability of color and shape. It means that if you want to apply classical imaging techniques such as shape pattern or color pattern, you are going to fail. Okay. The strategy that we followed was to study which geometric and color descriptions best define the mussel. Okay, then we define the numerical range of these descriptors only for mussel identification. In this case, we used these descriptors: area, compactness, elongation, circularity factor, major and minor axis ratio, average channel rate. And once the mussel is identified, everything else is a foreign body. Okay. It means that improves the performance, but it's very important to separate the elements in the scene of the camera. Okay. Another vision technology that currently we are working is hyperspectral technology, hyperspectral camera. In the infrared range. Okay, with this technology, we get 100 times more color information, and very important thing is that with the infrared light interacts with the molecular in the food matrix, and you can measure physicochemical parameters, and this information is called spectral fingerprint or chemical image. Okay, it's a mix or information of color and chemical composition. And with this, it means that with this technology, one material with the same color but different chemical composition can be differentiated with the hyperspectral cameras. Okay. We test this technology with mussels, and how you can see in the image, chemical image, is not necessary to separate the elements in the scene. Okay. Previously, you have to do a machine learning for doing the algorithm with the class or the pixels that you want to differentiate. Okay, but it's not easy to apply in a real production plant. Because you only see the surface. Okay. And finally, in 2023, we will use a hyperspectral camera to develop a mathematical model for nutritional measurement of the mussel. Okay. It means that only with taking a photo, we can measure humidity, protein, and salt. For develop this model, we use 150 samples. Okay, to make the model. And this is all my presentation.